Hello everybody. In this video we're going to review discrete distributions. This is problem number 1. A sign on the pumps at the gas station encourages customers to have their oil checked and claims that 1 out of 6 cars needs to have oil added. If this is true, what is the probability of each of the following? So this is binomial distribution. First, let's review binomial distribution formula. Binomial distribution is n choose x times the probability of success here. So let's call it success to the x times 1 minus success to the n minus x. So in our case, our probability, so this is p, this is 1 minus p, this is the probability, this is the 1 minus probability, which is the complement of the probability. In our case, our probability is 1 out of 6 cars, it says. So it's 1/6 is the p, 1 minus p is 5 out of 6. So if we apply the binomial formula, so 1 out of next 4 cars oil checked. So 1 out of 4, so 4 choose 1. 4 choose 1 by definition is 4 factorial over 1 factorial times 4 minus 1 factorial, which is 4 factorial over 1 factorial times 3 factorial. But I'm going to leave it as 4 choose 1 because the calculator takes care of this part. 4 choose 1 times our success is 1/6 and our x in this case is 1. 1/6 to the 1 times 5/6 to the 4 minus 1, which is 3. And the calculator here says it's going to be 0.38580. So it's 38.58%. So the answer is here in decimal, 0.38580. You can leave it in this form or you can leave it in this function form. So the part B is the same logic. This time 2 out of next 8 cars. So 8 choose 2 times our probability did not change. It is still 1/6 because we are still dealing with the same situation, same scenario, to the second power times 5 over 6 to the 8 minus 2, which is 6th. And your calculator executes it as 0.26047. 0.26047. And in part C, 10 out of 40 cars. And the same scenario. So 40 choose 10 times same probability we have to the 10th power, 5/6 over 40 minus 10 to the 30th power. And the calculator will tell you 0.059057. 0.059057. Problem number 2. In a game of roulette, a steel ball is rolled onto a wheel that contains 18 red, 18 black, and 2 green slots. If the ball is rolled 29 times, find the probability of the following events. The ball falls into the green slots 4 or more times. So this is the binomial distribution. Binomial with n, p parameters. So n is the number of trial, p is the probability of each success, is equal to n choose x times the success, which is p, times failure, which is 1 minus p, p to the x, and n minus x, 1 minus p to the n minus x. So we're going to apply the binomial distribution formula. Here our p is the probability. So here our probability is that the ball falls into the green slots. We have 2 green, 18 black, and 18 red. Totally 38 slots. And out of those 38, we are trying 2 greens. So 2 out of 38 is our p. Our p is here 2 out of 38, which is 1/19 if you simplify. and our n is the number of trial is 29 times. So our binomial 29, 1.19 parameters, and here we are going to interpret the ball falls into green slots 4 or more times. Let this event be A. So probability of A being more than 4 or equal to 4 is equal to 1 minus that A is less than or equal to 3. So here we can apply the binomial formula. We are choosing out of 29. Let's choose M because we tried 29 times, and 1 over 19 is our probability to the M, and failure is 18 out of 19 to the 29 minus M. However, we need to sum this up and subtract it from 1 because we are using the complement. So it's going to be 1 minus, and we are summing from M is 0 to 3. So we are calculating from the complement part, which is easier. Unless you would like to count up to from 4, 5, 6 up to 29, which is longer way to count. So 1 minus 0 to 3 is easier. And if you do this, if you plug this in your calculator, you're going to obtain, let me write it here, 0.3858, 0.3858. Part B is asking the ball does not fall into any green slot. So we're rolling the ball 29 times. And the ball that falls into green slot is 2 out of 38 because we have 2 green out of 38 total. But not fall into green is 1 minus 2 out of 38, which is 36 out of 38, is the probability that ball does not fall into green slot. However, we do it 29 times, so to the 29th power. So this is the answer. You can think it like this. You roll the ball the first time, this is the probability. And the second time, this is the probability that it doesn't fall. And you do this 29 times. So this 29 times, you can condense it in the power formula. Part C, let me clean here, is asking the ball falls into black slots 11 or more times. Okay, let's call this event C. So probability of that C is greater than or equal to 11 means that 1 minus the probability of C is less than or equal to 10. So we're going to count up to 10, which is easier or shorter way. And that's going to be 1 minus, we're going to use summation that M is starting from 0 up to 10, and we are doing it 29 times. Our probability is here, the black slots. So the probability that black comes, we have 18 blacks out of 38. So 18 out of 38 to the M. And the complement of this, or 1 minus this, is 20 out of 38 to the 29 minus M. And your calculator will tell you that this is 0.886238. 0.886238. The last part of the problem is again binomial. This time we're going to calculate that the ball falls into red slots 12 or fewer times. Okay, so this is going to be the probability of D being less than or equal to 12 times is the same as 1 minus that probability of D is greater than or equal to 13 times. So we're going to use again 1 minus summation from 13 to 29, and 29 choose M. Our success is red red is again 18 out of 38 to the m, and 1 minus p is 20 out of 38 to the 29 minus m, and the calculator will tell you 0.324105. 0.324105. For these type of questions, you need to remember that binomial with parameter n comma p, n is the number of trial, p is the probability of success, and choose x times, and if you're summing, normally it is n choose x times p to the x, 1 minus p to the n minus x, but if you're adding and counting, then you have to use summation sign, that m is starting from some point to some point. That's it for this problem. Problem number 3. In the United States, voters who are neither Democrat nor Republican are called independent. It's believed that 13% of the voters are independent. A survey asked 24 people to identify themselves as Democrat, Republican, or independent. What is the probability that none of the people are independent? So we know that the probability of that people are independent is 0.13. So the rest, 1 minus 0.13, is either Republican or Democrat, which is 0.87. So those are the parameters we're going to use for the rest, so I would like to keep it here. Now we know that 13% of the people are independent, but the question is asking the probability that none of the people are independent. So it is 87%, 0.87, to the power of 24, because we ask it 24 people, because we repeat this coordinate 24 times. You ask the first person, the probability that he's not independent is 87%. You ask the second person, you ask the third person, you ask the 24th person. So you have 24 of these that you can condense it as 0.87 to the 24th power. Part B, what is the probability that fewer than 4 people are independent? So this is binomial with the parameters 24, which is the number of trials, and p, this is n, this is p. P is the probability. Probability of independent, we knew it explicitly, 0.13. And this is going to be summation. We're looking for probability that are fewer than 4. So that's going to be from m is from 0 to 3. And this is going to be 24 choose m times the success to the m. Failure, which is the complement of 0.13, to the 24 minus m. This 24 is from the previous part. So if you plug in your calculator 0 to 3, 24 choose m times this function, you're going to obtain 0.61, 87, 81. So that's going to be the answer. So what is the probability that more than 3 people are independent? This is the complement of b, so that is 1 minus 0.618781. Or you can do like this. So we're looking for the probability that are more than 3 people are independent, which means 1 minus probability of 3 people are independent, which is m is from 0 to 3, 24 choose m, success is 0.13 to the m, failure is 0.87 to the 24 minus m. And if you plug in this your calculator, you're going to obtain 0.38, 1218, or 1 minus probability of b will give you the answer. Problem number 4. Suppose the number of cars in a household has a binomial distribution with parameters n is equal to 15 and p is equal to 65%. Find the probability of a house holding having 6 or 8 cars. So this is binomial distribution. We know that binomial distribution with parameter n p has n over x times p to the x 1 minus p to the n minus x density function. So here we're calculating the probability that the household has exactly 6 or 8 cars. So that is, out of 15, n is 15, we're looking for 6 cars, and p is 0.65 given to the 6, and 1 minus p is 0.35, and this is going to be 15 minus 6 is 9, plus having 8 cars, because it says or, so we're going to add it. So 15 choose 8, 0.65 to the 8 times 0.35 to the 15 minus 8 is 7. And if you add the sum in your calculator, you're going to obtain 0.1677. 0.1677. So what is the probability of that household is having 6 or fewer car? So having 6 or fewer car, that 15 choose m, let's call it m, to the 0.65 is the success to the m, 0.35 is 1 minus p, which is 15 minus m, and we're going to sum it from 0 to 6 because we're calculating 6 or fewer car, which is 0 car, 1 car, 2, 3, 4, 5 up to 6 car, and this summation will give you the answer 0.0421938. 0.0421938. What is the probability that household is having 10 or more cars? Is we can go from either sum from 10 to 15 like this, and using the same formula, or 1 minus 0 to 10 and the same parameters. And here you're going to obtain at C 0.564282. 0.564282. Fewer than 8 cars is summation from 0 to 7 cars. And again the same parameters. So we can copy paste this part. And you're going to obtain here 0.113331. 0.33, 0.113331. More than 6 cars. More than 6 cars, we can use the complement 1 minus having up to 6 cars, which is 0 to 6, and again the same parameters. And here you're going to obtain 0.957806. 0.957806. Problem number 5. Suppose that you randomly draw one card from a standard deck of 52 cards. After writing down which card was drawn, you replace the card and draw another card. You repeat this process until you have drawn 16 cards in all. What is the probability of drawing at least 8 clubs? This is binomial distribution with the parameters 16, which is our n trial, and 1/4, this is our p. Because probability of picking clubs in 52 standard decks, that we have 13 of each suits, and one of the suits is club. So we have 13 out of 52, which is 1/4 probability. So our binomial parameters are 16, 1/4, and what we want is at least 8 clubs, which is 8 clubs, 9 clubs, 10 through 16. And this is going to be 16 choose m times our p is 1/4 to the m, and our 1 minus p is 3/4 to the 16 minus m. So this is the answer. And if you plug this in your calculator, you're going to obtain 0.02713. 0.02713. For the experiment above, let x denote the number of clubs that are drawn. For this random variable, find its expected value and standard deviation. Let's go shortcut. Expected value for binomial random variable is n times p, which is here 16 times 1/4, which is 4. And variation by definition is expectation of x squared minus expectation of x, the quantity squared. But again, we're gonna go to shortcut. We're not gonna go to this definition, because in this case we have to find the expectation of x squared. So we're going to go to another definition of standard deviation for binomial, n times p times 1 minus p, which is going to be 16 times 1/4 times 3/4. So it's going to be square root of 3. Problem number 6. Suppose that you flip a coin 13 times. What is the probability that you achieve at least 6 tails? This is binomial distribution with the parameter 13, 1/2. 13 is the number of trial, 1/2 is the probability of success, which is 1/2 to get tail here. And we would like at least 6 tails. So our summation starts from 6 and above up to 13 here. And it's going to be 13 choose m times the success times success to the m, 1 minus success to the 13 minus m. And this is the answer. If you plug this in calculator, you're going to obtain 0.79473. Problem number 7. A jar holds 17 cookies. 11 are chocolate chip cookies and 6 are Brussels sprout cookies. You pick 3 cookies at random. What is the probability that you get exactly one of the Brussels sprout cookies? So here our denominator is the size of the omega, which is we are picking 3 cookies out of 17. So 17 choose 3 is our denominator. On the numerator, we're going to choose 2 cookies non-Brussels sprout and 1 cookie exactly Brussels sprout. So out of 11, we are picking 2 chocolate chip cookies, which is not Brussels sprout, and out of 6 here, we're picking our desired cookie. So the answer of this will be 33/68. And by definition, 11 choose 2 means 11 factorial over 2 factorial times 11 minus 2, the quantity factorial. Likewise, 6 choose 1 and 17 choose 3. Problem number 8. Let x represent the difference between the number of heads and the number of tails when a coin is tossed 44 times. Then probability of x is equal to 10 is. So let's illustrate the situation here. We were given the scenario that the probability of the difference of head and tails is 10, and we're computing the probability of this situation. We use head minus tail in absolute value because this is the difference of the head and the tails, the number of heads and the number of tails. And we know that we have 44 trials. So the number of tails is equal to 44 minus heads, or vice versa. The number of heads is equal to 44 minus tails, either. And we can substitute this for the tails here. In this case, our probability that head minus, instead of tails, we have 44 minus heads equals to 10. Now we can handle this absolute value. Absolute value by definition is equal to both positive and negative value. So, and if we simplify here, we're going to have 2h minus 44 equals to 10, or 2h minus 44 is equal to negative 10. And if we solve for h here, add 44 on both sides and divide by 2, then h will be equal to 27. Here, adding 44 on both sides and dividing by 2, we obtain h as 17. So we have two values of h, either 27 or 17 will give us this scenario. So if we compute the number of h27 and number of h17, we get the probability of head minus tail is equal to 10. And this is the binomial distribution with the parameters 44, 1/2. Here 44 is the number of trials n, and 1/2 is the probability of success 1/2. Either head or tails has the probability of 1/2. And this is the binomial distribution. We have 44 trials, and this is going to be 44 choose 27 for the first scenario here, times p to the 27 times 1 minus p, which is again 1/2, 44 minus 27. This is the first part of the problem. Plus, we have again binomial with the same parameters, but this time we choose 44, choose 17, and 1/2 to the 17 times 1/2 to the 44 minus 17. And this is the second part of the problem. And if we add this 2, we obtain 0.078029. So this is what we obtain. Problem number 9. Let the random variable x be the number of rooms in a randomly chosen owner-occupied housing unit in a certain city. The distribution for the units is given below. Is x a discrete or continuous random variable? Here our x is discrete random variable because for each integer we have some certain probability value, and actually if you graph it you obtain some dot plot. If it was continuous random variable, when we graph it we obtain smooth line, and for each value of numbers in between non-integer values we obtain some certain probability. Part B is asking what must be the probability of choosing a unit with 10 rooms. So probability, the total probability by definition has to be equal to 1. So probability that x equals to 10 is 1 minus probability of everything here. Probability of 3 plus probability of 4 until probability of 9 everything. And if you add everything up here, you see 0.98. 1 minus 0.18 is 0.02, so the probability that x is equal to 10 is 2%. What is the probability that a unit chosen at random has more than 5 rooms? So that is asking us that probability that 6 plus probability 7, probability 8, probability 9, and probability 10. If we add all these probabilities here, greater than 5, is 15 plus 5 is 20, 23, 24, and we already know 10. 24 plus 2 is 26, so it's 26% or 0.26. Part D is asking what is the probability that a unit chosen at random is not a 10-room unit. So probability that it is not equal to 10 is 1 minus probability of 10, which is 1 minus 0.02, which is 0.98. Anything but 10 is the rest. What is the probability that a unit chosen at random has less than 5 rooms? So that is the probability of 3, 4, that's it, because strictly less than 5, which is 28 plus 7 is 35, so 0.35 is the probability for E. Problem number 10. 6 men and 4 women are ranked according to their scores on an exam. Assume that no 2 scores are alike, and that all 10 factorial possible rankings are equally likely. Let x denote the highest ranking achieved by a man, so x is equal to 1 indicates that a man achieved the highest score on the exam. Find each of the following. So here our situation is we have 10 coordinates, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So probability that x is equal to 2 means that second coordinate is a man. That indicates the highest score achieved by a man. So for this, all we care is this first 2 rank, and we don't care the rest. So for the first coordinate, for probability that x is equal to 2, has to be woman, and we have 4 women out of 10 people, times, and the second coordinate is our desired coordinate that we care it has to be man. So it's going to be 6 out of 9 because there is no replacement here. This is like no replacement probability. For the third rank, we care only third coordinate here. And the first 2 coordinate has to be woman and the third coordinate has to be man. So for that scenario, that probability that x is equal to 3, our first coordinate has to be woman, which is 4 out of 10. Our second coordinate has to be woman as well, 3 out of 9, because there is no replacement. And our third coordinate has to be man, which is 6 out of 8 this time. So 4 out of 10 times 3 out of 9 times 6 out of 8 is the answer. For the fourth coordinate, our first 3 coordinate has to be woman and the fourth coordinate has to be man. So for the first coordinate we have 4 out of 10, second coordinate 3 out of 9, 2 out of 8, and this has to be 6 out of 7. So 4 out of 10 times 3 out of 9 times 2 out of 8 times 6 out of 7. For x is equal to 7, our probability is 0. Let's show why. For that, what we care is the 7th coordinate has to be man. Probability that x is equal to 7, first 7 coordinate has to be filled with woman, 5, 6, 7, and the 7th coordinate has to be filled with man. So this is going to be 4 out of 10, 3 out of 9, 2 out of 8, 1 out of 7, and it is exhausted, 0 out of 6. We don't have 7 women. We have to have at least 7 women to fill this gap. So this multiplies everything by 0. That's it for Discrete Distributions video. I hope you enjoyed. Thanks.